Hi gang, we're going to do section 3.5, that's implicit differentiation. Before I start, let's just be clear on the definition. This is explicit form because y is isolated. The dependent variable here is isolated, so we call that explicit form. Implicit form is when the y is blended in. And sometimes you can isolate for the y, and sometimes you can't. So it just, usually you just work with the form that it's in, but sometimes students will alter the form. All right, just real quick, I want to show you something. Okay, so if I asked you to find the derivative of this, you would do it very quickly, right? You'd say y prime equals 2x. Now, if I had asked you to find the derivative of, let's say, something that looked like this, you at first glance would be confused because you've never seen an equation formatted like that. Now, watch what happens when your brain goes through this. Don't rewrite it, just leave it as it is. I know you want to rewrite it, which isn't wrong. I just want you to think about this. If I take the derivative of this is 6x. Now, in this form, when it's in this altered form, students have a tendency to treat y like they would treat x. Like if they saw the derivative of an x, they would say 1, but that's wrong. The derivative of y is y prime. Now, you're sitting there probably going, what the heck did Professor Whelan just do? That doesn't make any sense. But you have to remember that since we've started derivatives, anytime we've had a y, the derivative has been y prime. I've never started with a y and said that that was a 1, ever. Never, never, ever. So you have to remember, no matter where the y is in the problem, its derivative is y prime. All right, that's the first thing. The second thing I'm going to show you, and this is going to be a little uncomfortable at first, but I highly recommend you do this because you're going to have to do it later on. So it's just going to be a little easier for you if you sort of like lean into it now. All right, so instead of writing y prime, I'm going to start with a new format. I'm going to start with dy dx. Okay, so this is equivalent to y prime. It's just fancier. Now, some of the reasons why we do this is that if you keep doing y prime, as these problems become complicated, very complicated, you're going to get confused who's who. It's gonna start to get really messy, and it's not going to get obvious. Like y prime looks very similar to y, and dy dt doesn't. Also, later on when we do related rates, you have to write it in this formula. And when we start integration, you're going to be writing things in this formula. So you can get away with not doing it now, and I'm certainly not going to make you do it on the test. But when you write things like this, it's like better information. It says I'm taking the derivative of y in respect to t. And later on in the course, we're going to be taking the derivative of the area in respect to time. Like what these variables are going to become very significant to you. And so we're going to be more particular about how we write things. Okay, but here it's sort of indifferent. All right, let me stop the first video here because that's my intro, and I'll pick up with solving some problems with you when I come back. Okay, gang, bye-bye.